Leicester is really pleased to be part of this Smart Spaces project. We've got 11 different cities, 11 different pilot sites in 8 countries involving 26 partners. Leicester as the UK's first environment city, and de Montfort University as a university that's been working closely with the City Council on energy and environmental issues for many years. So the Smart Spaces project is an extension of this joint working, and it's a way of trying to engage with building users and the public over quite a complex and relatively boring issue. So we've collected all this complicated information and we present it in a simple form on a website that any member of the public can look at.
The Smart Spaces system that we've designed is intended to make a very straightforward representation of energy consumption, even though it's quite a complicated idea. So we convert energy performance into a simple smiley face, and we list 25 buildings according to their performance. So the best performers are at the top and the worst at the bottom. And so if a building improves, then it moves up the league table, but if it deteriorates, if it uses more energy than expected, then it goes down the league table. So there's every opportunity for any building to go up to the top or to go down to the bottom of the list. If you click on a building, then you get through to a more detailed view of that individual building, which is a view that we often put up on a public screen inside the building.
Each building within DMU has its own plasma screen. Some of these screens are larger than others. We're sat in front of the largest screen in Hugh Aston. These screens are used to communicate key messages from the university to our stakeholders, and Smart Spaces is very much part of that. So we ensure that the message about Smart Spaces and messages about how buildings are performing is being communicated to staff, students and visitors, along with the other key messages from the university. When I've been talking to students about completely different issues and they flagged up the fact, oh, my building's doing really well, I've got a green smiley face, or my building's not doing quite so well, I've got a red frowny face. So students really like it, and again that's down to the fact that it's a simple way of engaging and communicating energy use within buildings.
If we walked into a building and saw a graph, we'd have to stay there for a couple of minutes and wonder, what does a graph mean, how to figure it out. But whereas the smiley faces will just pinpoint it straight away and let us know what's wrong, or if it's right, or if it's in between. Green
smiley faces mean that energy consumption is lower than expectation, and the red sad faces indicate that energy consumption is higher than expected. And to understand how that works in detail, you can click on the Detail tab and see the half-hourly calculations. So this is now 3 charts of energy data showing half-hourly consumption as a black line, and a range of values, which is the model prediction as coloured zones. So you've got a red zone, which is high consumption, and a yellow zone, which is kind of normal consumption in the expected range, and green range is low consumption. And the smiley face is a direct reflection of how far the black line is into the red or into the green or in the yellow range. And the model behind that is quite sophisticated, but we try and remove that sophistication from the visualization and show something very, very simple and easy to interpret. Smart Spaces also includes a forum which allows users to have a conversation online about their buildings. So not only are we providing a source of information in the smiley faces, we're also giving users a way to act on that information by having conversations with other users in their buildings and other energy professionals who are interested in that and who can act on that.
We have selected 7 leisure centres, 7 schools, 2 community centres. We've also tried to include things like a library, a museum, one of our admin offices, and we've also got something quite unique, which is like an entertainment and events venue. As an energy person myself, I find it extremely useful because at a glance I'm able to identify where the opportunities are, because the league table's telling me something's changed in terms of performance in that building, and it will tell me whether it's the electricity, gas or water at a glance. So I don't have to spend a lot of time. People are busy, they want to find a quick way of identifying or unique way of identifying whether something's wrong in a building. a lot of the schools are particularly very interested in this type of tool. They understand the basics of it, but don't always look at it in more detail. But in the energy management team, when we've identified this, we've reported it to the site, and they've sort of said, "Oh, I noticed that, but do you know what to do with it?" And that's where the engagement starts, and you're sort of saying, if you look at it in this way, if you open that profile up that gives you the detail, it will show you that the heating system was coming on earlier than previously, and therefore there's opportunity for them to make savings.
Like me, I'm not that much aware of the electricity, gas and water that's going around in the building. And I think it's good for us students because we'll become more invested in trying to help save water, gas and electricity in our buildings.
The key thing is the combination of the dashboard based on the complex models with the online forum with people to share their knowledge and experience.
Yeah, I mean, if students were more aware and understood how easy it is and understood how it helps the environment, I think, yeah, it could be used in a lot of buildings, not just in DMU, but in a lot of universities as well.
Recently, we had excessive consumption on a Saturday, but it wasn't a problem. It was our open day when buildings use more electricity, gas and water. So it's very useful to be able to get an indication of how our buildings are performing and for people to be able to comment on the performance of those buildings.
Anything that identifies a problem with a building at a glance saves me a lot of time and effort and cuts wastage in that particular area, whether it's electricity, whether it's gas or water. If I can identify it and fix it quickly, it's doing my job very effectively, I think.